All right, so 4-3 is just 4-2, sorry, is just taking 4-1 to the next step. So we practiced graphing a little bit yesterday, but by the time we leave here today, you should be masters at doing this stuff, okay? On the quiz tomorrow, there are 7 questions, 6 straightforward with one thing that you're finding, whether it's find the vertical asymptote, or find the horizontal asymptote, or find the slant asymptote, or find the hole, or find the domain, or find the zeros. It will be something specific like that. And then there is one question that is worth 40 points, so it's a big chunk, that has all of those parts and then graph, which is basically what we're going to do today. So as you go through all the examples today, you are practicing all those other parts. So like you're doing both 4-1 and 4-2 in today's. This would be the order you're going to check. You're going to do your equation or your graphs. You're going to start by simplifying your expression. So you want to always check and see, can you factor it? If you can factor it, can you cancel something out? If you can cancel something out, now you've got a hole. If not, you'd continue, and I go in order of asymptotes. I tend to do the vertical asymptote, then the horizontal asymptote, then the slant asymptote. So as a reminder, vertical is by setting your denominator equal to 0. Horizontal has 2 parts. If it's x to the n over x to the m, and n is less than m, then my horizontal is y equals 0. And that has to have the y equals, just like your vertical has to have the x equals. If n is equal to m, then my horizontal asymptote is the leading coefficient of my numerator over the leading coefficient of your denominator. And if n is greater than m, there is no horizontal asymptote. Yep.
So if it's y equals 0, would that still count as like being 1?
Yep. It would be the x-axis. And then the slant asymptote comes if n is 1 more than n. So if the exponent in the top is 1 more than the exponent in the bottom. And to find those, we divide numerator by denominator. And then I set y equal to the quotient without the remainder. So we ignore the remainder. And we will get a linear equation there, or a line. That will be your slant asymptote.
When you do the long division where you divide 2 equations, do you have to make sure there's no holes in each one of them?
Well, the holes you're going to start from the very... You mean no missing terms?
Yeah.
Yes.
Okay.
Yep. All right, then you're going to find the zeros, which will appear on your graph as x-intercepts. So in the homework last night on WebAssign, it asked for the x-intercepts, and it wanted it in coordinate point form. The instructions on the quiz say zeros, so you can literally just list those zeros, okay? The y, and so for these, we set our numerator equal to 0. That's how I would find... That's how I would find my zeros. To find the y-intercept, and this is going to be in coordinate point form, so it's going to be 0, comma, a number. And we plug 0 in for x. Yep. And then you'll be lucky enough to have a graphing utility that will help you see where your curve goes. If you didn't have a graphing utility, or your graphing calculator is not working the way you want it to, or you're unsure based on like the zoom of it, you can always plug in points to see where your graph goes. So that's your fallback. If by chance you didn't bring your graphing utility with you tomorrow, that's all you're going to be able to do is plug in some points. So you're going to plot your asymptotes, your zeros, your y-intercepts, and then the rest is going to come from plugging points. The other thing that the homework asks you for and your quiz is going to ask you for is domain of the function. Domain is the denominator, like it's when the denominator can't equal 0. Denominator, if I could spell right, cannot equal 0. The domain and the x coordinate of the whole are the only things that come from the original if there's a whole. Everything else comes from after. So as soon as you get your vertical asymptotes, you would say like x equals 1 and x equals -1. You can reverse that to get your domain. And this will always be an interval notation. So today we're going to practice all of this. We're going to act as though each question is that last question on your quiz. All right, here we go. So number 1, g of x equals 3 over x minus 2. So the very first thing I do is see if I can factor this. Can you factor the numerator or the denominator? No, which means I can move directly into vertical asymptotes. So the vertical asymptote, I set my denominator equal to 0. And I get x equals 2. Again, make sure it's x equals, otherwise you just lost points. On a 10-point question, I'm going to cut that in half. Yep. Now, based on that, I can go to my domain, because if there's an asymptote at 2, that means my domain is the reverse of that, right? Domain says this can't equal 0, so x cannot equal 2, and my domain goes from -infinity to 2 and 2 to +infinity. So your domain is the exact reverse of your asymptotes. Yep. Yeah. All right, then I would go to horizontal asymptote. What's true about the exponent in the numerator? X is raised to what power in my numerator? 0, and in the bottom, 1. So that relationship is? The top is less than the bottom, yes? Which means y equals 0 is my horizontal asymptote. And that also tells you no slant asymptote. Good. Then I go to my x-intercepts, or my zeros, because that's the word that the quiz says. And to do that, I set my numerator equal to 0. Can 3 ever equal 0? No, so there are no zeros or x-intercepts. It's never going to cross through the x-axis.
Why is there no x-intercepting?
Because that numerator can never equal 0. So if there's no variable in the top, it's never going to hit. Yep. And then the last thing I want to find is my y-intercept. And for that, I plug zeros in. So I'd get 3 over 0 minus 2, which is 3 over -2. And that y-intercept would be 0, -3/2, or 0, -1.5. You can write it either way.
Wait, since there is no, you just put 0.
You would put none, not 0, none.
But for that, when you fill in the x, you just put 0.
No, the x-intercept has no bearing on the y-intercept. For y-intercept, you always put 0 in for the x. It doesn't matter that there were no, yeah.
You're right.
It's okay.
So for like the x-intercept, you would put a 0 in the y.
Correct. Like when you write it out, you mean?
Yeah.
Yeah, but it's going to say zeros, so you can just list the x values. You don't need to give it to me in coordinate point form.
All right.
Yep.
Okay.
Okay. All right, so now I'm going to go to my graph. I'm going to plot all my asymptotes. So the vertical asymptote is at x equals 2. It's a vertical line that passes through 2. My horizontal asymptote is at y equals 0. So it's a horizontal line that passes through 0. There are no x-intercepts, and my y-intercept is at 0 and -1.5, so it's down here. Just that alone tells me my graph is going to pass through here, And then if it's an x squared in your original equation, they can be side by side, but if it's not, they are typically in opposite corners like this. But I don't have to guess that because I have my graphing utility. If I didn't have a graphing calculator for the quiz, I would have to plug in a point to the right of this vertical asymptote. So I'd have to plug in something like 3 and see if it's above or below that horizontal asymptote. That's how you would know where that curve goes. The good news is you've got your graphing calculator, so you don't need to do that.
Can you just type in the fraction at the beginning?
Yes. So I'm going to go record. Okay, so I'm going to go to my y equals. And then you have two options here. One is type it in, make sure you use your parentheses to group together the denominator. The other thing is if you go to the math button, which is under the green button, if you go to math and you arrow over to FARC for fraction and you hit enter on that first one, which is n/d, it gives you the little fraction. And you can type it in that way too. So it would be 3 over, what is it, x minus 2, right? X minus 2. So you can type it in that way, or you can write it as 3 divided by, but you have to open and close parentheses for the x minus 2. If it has more than one term, you have to group it with parentheses.
Wait, so how do you get to the fraction?
You go math, so the button next to the green button that says math. Math. Go all the way over to the last one that says FRAC and click on n/d, that first thing.
Oh, you just hit alpha and hit the x.
Alpha X. Yeah? Good to know. This alpha? You mean from the beginning? Yeah. I'm going to go. Again, because there's a million different kinds of calculators, they all operate differently. I'm going to try to teach you as much as I can, but I obviously can't get them all. If you have the fraction thing, then it's the top one. If you don't and you have to write it in with parentheses, you have to make sure you group it. If there's 2 terms in the numerator, you got to group them with parentheses. If there's 2 terms in the denominator like this one, you got to group them with parentheses. Okay, then I hit graph. Slow and steady, but there it is. Okay, top right corner, bottom left corner, just like we thought it was going to be. So then on your actual quiz, you will give me the asymptotes, you will give me the zeros, like all those things are going to have a little line next to them that ask for them individually, and then it will say graph, and on your graph, you need to show the asymptotes. Remember that your graphing utility is not going to show the asymptotes. You've got to actually include them on the graph that you draw, though. Questions, because we're just going to do that on repeat. All right, let's keep moving. So number 2, I'm going to start by doing what? Before that, check to see if I can factor it. Can I factor? No. Now I go vertical asymptote. So vertical asymptote, I set my denominator equal to 0. There's not even any work to solve for there. That is it. X equals 0 is my vertical asymptote. I'm going to remember the x equals 0, or I'm going to dock myself 5 points, which is not something I would want to do. Then my domain is the opposite of that. So if there's an asymptote at 0, domain can't equal 0, which means my domain is negative infinity to 0, 0 to positive infinity. Then comes horizontal asymptote. This time the exponent and the top and the bottom are the same. So this is my leading coefficient time. Y equals the leading coefficient on the x to the first in the numerator, which would be 2, over the leading coefficient of the x to the first on the bottom, which is 1. So y equals 2 is my horizontal asymptote. Which means what about slant? None. Then I want to find my zeros. So zeros or x-intercepts, I set my numerator equal to 0. 2x minus 1 equals 0. 2x would equal 1, and x would equal 1/2. And these you can just list, like 1/2. If there was another one, 1/2 and 2, I would do 1/2, comma 2. Plus and minus 2, I do plus and minus 2.
What did you find zeros again? Oh.
Numerator equal to 0. Then I go y-intercept, and y-intercept I plug zeros in everywhere there's an x. So 2 times 0 minus 1 over 0. And what happens here? What happens when you divide by 0? Undefined, which means there are no y-intercepts. Yep.
For zeros, you don't have to write it in coordinates.
No. If it said x-intercepts, it would need to be in coordinate point form. I don't know if I'll mark it wrong if it is in coordinate point form because WebAssign asks for x-intercepts, but it will say zeros, so you can just list them.
Okay.
All right, so now I'm going to plot all this information. So my vertical asymptote, which is at x equals 0, vertical line passing through 0. Horizontal asymptote is at y equals 2, so horizontal line passing through where y is 2. No y-intercepts, but I do have an x-intercept at 1/2 or 0 at positive 1/2. So I know it's in the bottom right corner. If I didn't have a graphing calculator, I'd have to plug in one of these points. So if I plug in like -1, I'm checking to see would it be above or below my horizontal asymptote. And it should be above because this one goes corner to corner. Without a graphing with the graphing utility though, I'm just gonna graph it. So I'm gonna go to the first one. I'm actually gonna clear it out so that you can see what would it look like if I had to do both. Okay, this time my numerator is 2x minus 1. So if I don't have the fraction, I have to group it. 2x minus 1, close my parentheses, divided by, open the parentheses again, and it's x. Actually, it doesn't need the parentheses because it's only one term, but for the bottom. Or I do, again, math, arrow over to FARC, and over D, and I do 2x minus 1 over x. And then I hit graph.
Why is yours turned red?
Because I did it twice. So it does it blue for the first equation and red for the second one. Like when I go to my y equals, I wrote it in twice. Yeah. All right, so now I know it's top, left, bottom right. Easy, right? We're gonna do it again. All right, step 1. DEL, 2 over from the right. Factor, right? This time I can factor that denominator. Factors of -2 that sum to 1, to -1. -2, positive 1. Can anything cancel? No. So there's no holes, which, there will be a line for that as well. So all the other ones you would have written no holes, okay? There will be that. Vertical asymptotes, I already did the work of factoring, so now all I got to do is split it. So x minus 2 equals 0, and x plus 1 equals 0, and I get x equals 2, and x equals -1. So there are 2 vertical asymptotes. I'm going to put an x equals for both of them so that I don't lose points because it has to be an equation. Which means for domain, it can't equal 0, which means it can't equal -1 or 2. And in interval notation, that means I go from -infinity to the smaller one, which is -1, union -1 to the bigger one, which is 2, union the bigger one, which is 2 to positive infinity. So there are 2 things it can't equal, then I have 3 sets of parentheses in my domain. Then comes horizontal asymptotes. So what's true about the exponent in the top and the bottom? What's the relationship?
The one at the bottom is higher, so it's 0.
So y equals 0, good. N is less than m, so it is 0, which means still no slant. Okay, and we said it before, but no holes. Then I want to get my zeros. So I set my numerator equal to 0. X equals 0 means that's where it's going to cross the x-axis. Y-intercepts, I plug 0 in for x. So I get 0 over 0 squared minus 0 minus 2. And it's 0, 0, which is consistent with the x-intercept, or the 0 we found. Because if it's 0, then it also has to be a y-intercept.
These zeros are x-intercept, right?
Correct. All right, so now I go to my graph. I have a vertical asymptote at negative 1 and a positive 2. I have a horizontal asymptote at 0. And an x-intercept and a y-intercept at 0. So when we first went over horizontal asymptotes yesterday, I said the graph can't touch the vertical asymptote, but when they are split like this into 3, there are times in which it actually will cross through the horizontal asymptote. So yesterday's we had a parabola that actually bounced off that point. This one's going to look completely different. So when I go to put this, if I didn't have my graphing utility, I'd have to plug in a point from this section of my graph, from this section of my graph, and this section of my graph. So it's a lot of plugging in if you don't have a graphing utility. Obviously, every time you do it, you got to remember to make sure you bring it with you tomorrow. Okay, so now I'm going to type that into my graphing utility. So x divided by, open my parentheses, x squared minus x minus 2. And I hit graph. And that's what it looks like. So your typical graph on an inequality, or when you've got something that's like squared in the bottom, is you're going to have more than one asymptote like that. Okay, and when you divide it into 3, you can either have them, outsides will both go in one direction, parabola in the other, or something like this where you get that cubic shape in between, and then one curve goes up and one curve goes down. Yep.
How do you know that there's no holes again?
Because I couldn't cancel anything from the beginning. So if when you go to factor from the beginning, you can cancel something out, then you know that there's a hole.
Okay.
Yeah.
So, like,
Those points. All right, go to 4. So what's different this time is what?
but you can,
There's going to be a hole because I can factor the top. This is the different 2 squares, and the bottom. And the x minus 3 cancels. So there's a hole this time. And the x is where x minus 3 would equal 0, which means there's a hole where x is 3. Now listen to me carefully because we didn't discuss this yesterday. The domain, even though we canceled out that x minus 3, it still can't equal 3. So domain and the x coordinate of your hole come from the original equation, which means that I don't cancel that before I find domain. Domain says it can't equal 3 and it can't equal -1. So domain still includes that because a hole stops my graph. So domain includes what we canceled out. It can't equal it. The hole there will stop your graph.
So the domain and the x-intercept
And the x coordinate of your hole. The 3 that we just found. Now everything after this, we use our updated x plus 3 over x plus 1. So the only 2 things, if there's a hole, the only 2 things you get from your original are the x coordinate of the hole and the domain of the function. Now everything after this, we use this updated, simplified. So if I take the hole, I take the 3 and plug it in, I get 3 plus 3 over 3 plus 1, 6 over 4, or 3 halves is the the y coordinate of your hole. So you are going to get a question that says find the hole. It's going to be a 10-point question and just finding the hole. But then it could also show up in your big one where you're graphing.
Did you already see how many questions?
Yep, 7. 7, 6, where it's going to ask you for one individual thing, and then the 7th one that's 40 points, that's going to ask you for all of it. Yes?
So for the whole, you just plug in the X part of it
Into the new one, into the updated, simplified one. And remember, a graphing utility will not show you a whole. So there's no hope for that. Like, you can't graph it and look for it. It doesn't appear. All right, so now I'm going to go through all my regular stuff based on my simplified. So my vertical asymptote would be that x plus 1 equals 0, which means x equals -1. My horizontal asymptote, they are both the same exponent, so it's the leading coefficient. It would be y equals 1 over 1, which is just 1. There is no slant. My zeros come from my numerator, so x plus 3 equals 0, so x equals -3. -3 is a 0. And my y-intercept comes from plugging in 0, 0 plus 3 over 0 plus 1, which is 3. Then I go to my graph. So vertical asymptote at x equals -1. Horizontal asymptote at y equals 1. No slant. 0 at -3, and a y-intercept at 0, 3. I already know where my curve's going based on that. I don't even need to check my calculator. Obviously, I would recommend it, but you don't even need it. When I go to plug this into the calculator, you can either type the original one or your simplified one. As a matter of fact, you can type them both and make sure they're the same. That probably wouldn't be a bad idea. So I typed in the simplified one. I typed in this one, and I got this graph. What the graphing utility doesn't have that you need to make sure you add is that there's a hole. So when it says there's a hole at 3 and then 3 and 3/2 or 1.5, there would be a hole on my graph at that point. So it's still going to pass through that point. The graph will still go through that point, except there should be a hole. So at 3 and 1.5, there should be a hole, and then the graph would continue before and after. And the graphing utility is not going to show that. So you just got to make sure that when you do graph with the hole, that you include the hole as part of your graph. This one has a slant. I'm going to work through the rest of these on the video, okay? Okay, so for number 5, the first thing we're going to do is take the x out from my numerator, and nothing cancels. So it did factor, but it doesn't cancel, which means there's no holes. Then I'm going to go to my vertical asymptote. So set my denominator equal to 0. X plus 1 would equal 0, and x equals -1. That's going to be your vertical asymptote. Horizontal asymptote, the exponent in the top is more than the one in the bottom, which means there is none. It is specifically one more, which means this time there's a slant asymptote. So to find the slant asymptote, we're actually going to divide the numerator by the denominator. This time it's in order, but you're missing that constant in the numerator, so you can add on the plus 0. And you can either do synthetic or long division with these. Obviously, I would recommend synthetic. So it would be 1, -1, 0. Draw your box and put the opposite of what follows x on the outside, so -1. Bring down the 1, multiply it by the -1, put it in the next column and add it. And then I completely disregard the remainder, so you don't even need to do the next step. Just remember that the -2 stays without the x, but the 1 gets the x. And then it is y equals what you get, x minus 2. Then I would find my zeros or x-intercepts by setting my numerator equal to 0. We already factored it, so x times x minus 1 equals 0, which means split and solve, and I get 0 and 1. So there are 2 times this graph is going to cross the x-axis. And the last is your y-intercept. For that, I'm going to plug 0 in. And I'm going to plug it back into the original just because it's easier. And I'd get 0 over 1, which is 0, which is consistent with the x-intercept also crossing 0. All right, now I go to my graph. My vertical asymptote is at -1. My horizontal asymptote does not exist. My slant is at y equals x minus 2. So this is just a typical line with a y-intercept or a b at -2 and a slope of 1 over 1. So from there, rise 1, run 1, up 1 over 1. So I can go in either direction, and I'd get my slant asymptote, which looks like that. Then my x-intercepts or zeros are at 0 and 1. So I know my curve is in this corner. And with slants, they're always opposite, which means it's going to go in this corner without even needing to use my graphing utility. When I plug this into the graphing calculator, my graph looks like this, which is consistent with what we just found. And then don't forget, it's going to ask for domain. Domain is the opposite of your vertical asymptote. So if x equals -1, then domain would be that it cannot equal -1. So the domain would be -infinity to -1 and -1 to positive infinity. If you look at your graph, all the x values should match. There are values coming from the left up until that -1 where there's a vertical asymptote, and then the x values continue after that. So it's consistent with your domain. Okay, looking at 6, I'm going to factor the numerator x minus 2 and x plus 1. And the x is plus 1 in the numerator, minus 1 in the denominator, which means they don't cancel. So even though you were able to factor it, you're not canceling, which still means there's no holes. My vertical asymptote, x minus 1 would equal 0, so x equals 1. My domain is the opposite of that. So x cannot equal 1, meaning -infinity to 1 and 1 to positive infinity. Horizontal asymptote, the numerator is 1 more than the exponent in the denominator, so there's none. It's 1 more, so there is a slant asymptote. I'm going to divide. So the numerator has all the terms, 1, -1, and -2. Opposite of what follows x goes on the outside. Bring down the 1. And the last column we ignore. The 0 means my b is 0, but the 1 still gets the x. So my slant asymptote is at y equals x. I don't know why I wrote nones here. Sorry, it's just none. All right, now I'm going to go find my x-intercepts or my zeros by setting the numerator equal to 0. We already factored it. So I just split and solve it, and I get x equals 2 and x equals -1. And the y-intercept, plug in 0 for x, so x squared minus 0, or sorry, 0 squared minus 0 minus 2 over 0 minus 1, -2 over -1, which is 2. And then go to your graph. Vertical asymptote at x equals 1. Slant at y equals x. So the b here would be 0. I'd start at 0, go up 1 into the right one, or down 1 into the left one. There are 2 x-intercepts, -1 and +2, which tells me already my graph is going in this corner. And with a y-intercept at 2, my graph is going in this corner. I don't even need my graphing utility to verify, but if you did graph it, it would match. All right, 7 we kind of graphed yesterday, so I'm going to do it kind of quickly. But we can't factor it, so there are no holes. My vertical asymptote, x would equal 0, which means my domain, x can't equal 0, -infinity to 0. 0 to positive infinity. There are no horizontal asymptotes because the 1 in the numerator is more than the 1 in the denominator. but it's only by 1, so there is a slant. This time I'm missing my 0x. So I get 3, 0, 1, and this would have a 0 after it. Bring down the 3. Ignore the remainder. The 3 gets the x, so my slant is y equals 3x. When I find my zeros, 3x squared plus 1 would equal 0. 3x squared would equal -1. X squared would equal -1/3. And when I go to square root it, there is no real number, so there are no zeros. And if I find my y-intercept, 3 times 0 squared plus 1 over 0, this would be undefined, so there are also no y-intercepts. My vertical asymptote is at 0. My slant is at 3x plus 0, which means my y-intercept is, or b is at 0, up 3 into the right one, or down 3 into the left one. And there's my slant. It doesn't cross anywhere on my x or y axis, which is consistent with it being in the opposite corners here and here. Again, you could use your graphing utility to confirm that, but there's my graph. All right, so homework for tonight is to complete the review for the quiz. It's going to take you through a whole bunch of 4.2 examples with all of it built in together. And then remember, your quiz will separate some of it out, but it will build it all together. So you want to make sure you can answer all the questions, all the parts for all the questions. Have a great day.